So hello everyone, my name is Wael Ben Amara and today I'm going to be presenting the private class data, which is a design pattern. So this presentation is part of the CIS 476 course at the University of Michigan Dearborn. So first let's start by going through the outline of our presentation. So first we will present the definition of a design pattern, then we will state some problems and suggest solutions pertaining to our design pattern. And then we will present a proper definition for the private class data, and then we'll explore its architecture and see some implementation examples. So let's start by defining a design pattern. So generally, programmers face some problems and constraints while programming, and these constraints are generally repeated and they are generally common. So software communities came into play and decided to solve these repeatable problems by making some unified solutions that are called design patterns. So design patterns are generally considered as reference templates that coders can use in order to avoid some problems and make their code easily maintainable, scalable, and reusable. So let's pass to the problem statement. So let's suppose that we are maintaining a login web app and like Facebook or Instagram, and we are actually required to make the username displayed on their dashboard. So let's suppose that by mistake, instead of referencing the username variable, we referenced actually the password variable. This could actually occur especially when we are using IDEs that auto suggest some variables. So at the end, we can have the password variable displayed as plain text in our dashboard, which could be a bit infringing for some policies. Another problem is actually when we are referencing or when we are actually using an app that is consuming an API. So generally APIs use API keys in order to authenticate with the host. And if we are using a cryptocurrency related API, it is generally given once. So the API keys should be well preserved. And generally, programmers store API keys somewhere in their project. So let's suppose that by mistake they have accessed these variables and they have modified one of them. So our keys will be lost forever. Also, another problem is when we want to declare a variable as a variable that should be hidden from any bad manipulation, but actually this variable cannot be declared as final. So the solution to all of these problems is actually to use a specific pattern, which is called the private class data. So this design pattern is actually based on the encapsulation concept for attributes, but it is actually used for classes. So this design pattern enables hiding specific data and it limits the accessibility for these attributes. So now let's go to the formal definition of the private class data. So the private class data is a design pattern that limits the right access to a class attribute. So it is actually performed by separating or dividing the data class into two classes. The first class is actually the data class and the second one is the main class. The data class represents all the attributes that should be hidden and they should be declared as private. And the main class actually should have as attribute an instance from the data class. So this instance of the data class will hold all the attribute data from the data class. Also, we can specify which variables to be presented in the data class and which variable to be presented in the main class. And if you want to hide some variable or protect some variables, we can put them in the data class so that they have an extra layer of encapsulation. So now let's go to present the architecture of this design pattern. As you can see, it is a bit different from the usual encapsulation process. So the one that we have in front of us right now is the usual encapsulation process. And as you can see, we have a login and password that are private attributes, and then we have their getters and setters. So these variables are actually accessible from that class, and they should be accessed through the getters and setters if they are used from outside the class. And the design pattern we are referencing actually consists of dividing the class into two classes, as we said previously. So we can see that we have a user data and a user class. So the user data contains all the attributes that we want to protect, and these attributes are generally presented as private attributes. And then we can see in the user class we have an instance of a user data. So that instance will actually hold the login and password of that user. So we can see that we have an extra layer of protection and an extra layer of encapsulation. So in order to access, for example, the password of the user, it needs to be something explicit by the programmer. So he should first access the user instance and then access the user data attribute and then access the login and password. So we can see that we have a sequence of accesses. So this will remind the programmer that he is accessing the login and password, which is really encapsulated in the user data class. So now let's have a look at the implementation using the Java programming language. So this is the basic implementation. So we can see that we have the private login and password and the normal getter and setter with the constructor. No, actually we don't have a constructor in this class. So let's go to the private data class implementation. We can see that now, as usual, we have the user data and the user main class. So the user data, we have moved all the variables, all the attributes which are the login and password, we have moved them to the user data class, and we have actually only allowed the access to the login variable. So to set the login variable, and then for the user main, we have actually specified as attribute and the user data, and then we have specified a getter for that user data. So let's have a demo related to this design pattern. So actually, okay, let's see here. So here we have a user class, we have a login and password, and we have the getter and setter for the login and password, and then we have, so this is the basic implementation of that class of the encapsulation, and then we have the user data class, which is a class that will hold the attributes login and passwords, and we have the user main, which is used as interface for the data holder, which is the user data. So we can see here in the user data we have instantiated as attribute a user data object, and then the user data object will be passed in the constructor, and then we can see that we have a getter and setter for that data. So for our application, which we're gonna test today is actually this one. So let's execute it. So actually, when we execute the application, we get displayed a user with login well and password 123 was created, and the data was retrieved from the user class. Okay, so all the data was retrieved from the user class, since data was stored in the user class. And then a user with login URL was created. If you remember, we haven't specified any getter for the password. And then we have data was retrieved from user data. So if we come back here, we can see that once we click the button that says before private data class, we have actually the access to the data only by accessing the u.getLogin and u.getPassword. However, in this one, after the private data class, we have actually to go through an extra So for the demo part, we'll consider presenting it part by part. So the first part is actually the basic implementation of the user class. So as you can see, we have the private attributes, which are the login and passwords, and we have with them their getters and setters. And then for the application of the private data class, we have divided the user class into user data and user main. So the user data will actually hold attributes that we want to hide. So, and since we only want to retrieve the login, so we have only set the getter and setter for the login, and we omitted implementing anything for the password. So it won't be able for the programmer to set or get the password. So we have the main class, the user main. So as you can see, it has as attribute a user data, and then we have here the constructor, and then we have the getter and setter for the user data. And then first, let's have the execution of the demo application. So, okay, so as you can see here, we actually have the first one will show us like how the code behaves before applying the private data class, and the second button will show us how the code behaves after applying the private data class. So actually, when we click on the before button implementation, so our name, so the login and our password, and we were able to have the name of the class from which the data was retrieved. So we can see that the data was retrieved from user. And then if we execute the same functionalities, but after the private data class implementation, we can see that we only retrieved our login, and then we can see that the data was retrieved from the user data. Okay, so actually if we go back to our code, we can see that before the private data class implementation, we only had to use the users, getters, and setters. So we have the user defined here with his name and password. And then in order to access these attributes, we only had to specify then dot get login and then get password. So it's only one layer of encapsulation. And in order to have it in order to avoid any bad manipulation, we added an extra layer of encapsulation. So as you can see, we have a user data as an object, and then a user main, which is actually a user. So we created from that class a new instance, and we have passed to it the data. And as you can see, in order to retrieve that data, we had actually to go through two layers of encapsulation. So in order to retrieve the login variable, we have actually specified the get user data, the getter for the data first, and then the getter for the login. So actually we had to be very explicit and very precise when we had to retrieve our data. So this avoids any unintentional mistakes or any bad referencing or any bad manipulation. So that's all, and thank you for watching this video.